In this lesson, we're going to be taking a look at factoring polynomials. Now, factoring is basically the distributive property in reverse. So to start with, I'm just going to do a quick little practice and refresher showing you a couple problems using distributive property, and then we'll see how we can then factor, because I really want to make sure that the existing practice of distribution is firmly in mind. Otherwise, you're not going to be able to turn it on its head and go the other way. So remember, when we're distributing, that's how we're going to expand something like this first one here. I need to multiply whatever is out front into both terms. And so that's going to give me 5x to the 6th plus 40. And that one is then expanded. You'll notice that as I take a look at this final answer, that 5 multiplies into both of those terms, because that's how I got them. I multiplied by 5. That's going to be important to remember when we get to the factoring part. All right, then I'm going to do the same thing for the next one, where I'm going to be multiplying 6 into every single term. And so in that case, that would give me 18x to the 7th plus 30x squared minus 60. And that would be expanded then. Now, the factoring truly is the exact same thing, just in reverse. We have to figure out what number or other term could have been multiplied into it in order to be able to get there. So for our first one here, we're factoring the binomial. What do I see that I could divide out of both of these terms? Yeah, looks like 5 can come out of both of them. And so what I'm going to do then is I'm going to start by writing the 5 outside of the parentheses, because that's what I'm pulling out of both terms. And just like with distribution, I multiply into both. In this case, I will have to now divide both of those terms by 5 to see what is left behind. So 5x cubed divided by 5 just leaves me with x cubed. The minus stays a minus, and then 35 divided by 5 is 7. That is then factored. That's the big idea of what we're going for. It's just going to be a matter of seeing some of the little nuances that happen along the way from here, because there are a couple little things that sometimes get tricky. All right, let's go ahead and practice that one more time with that second problem. So I again need to look at all of the terms. In this case, that means looking at all 3 terms, and I have to figure out what goes into all 3 of them. Now you'll notice that in this last term, there's no x, which means I can't pull any x's out. So that tells me I'm just focused on numbers. So then I can just look at the 18, the 15, and the 24 and say, what can I divide all of those by? And I can see that I can divide all of those by 3. So the first thing I do is I write the 3 outside the parentheses. Having done that, I now can go ahead and divide each of the 3 beginning terms by 3 to see what is left behind. So 18x to the 5th divided by 3 will be 6x to the 5th. The plus stays a plus. 15 divided by 3 is 5, so 15x divided by 3 is 5x. The minus stays a minus, and 24 divided by 3 is 8. And there is our factored form. Now, in all of those examples, we were just dealing with a number outside the parentheses. Notice now we're going to start taking a look and seeing what happens when we have an x outside the parentheses. The basic idea of distribution is still going to be the same. We're going to multiply whatever is out front of the parentheses into every term inside. So in this case, I'm multiplying my monomial x squared by the binomial 7x minus 4. So if I'm going to do x squared times 7x, that means I'm going to end up with 7, and then x squared times x is x cubed. Because if I'm doing x squared times x, that really means I'm doing x times x times x, because x squared just means x times itself twice. And you notice then that's a grand total of 3 x's multiplied together, which is why we then write it as x cubed. Okay, so we got 7x cubed, and then minus x squared times 4. Now, I don't really want to write it here as x squared 4, because that looks kind of weird, right? We always want to put the number first, so we're going to write that then as 4x squared. And that's as good as that can be when we do that. Okay, now we'll repeat the process with the second problem on this page here. So I'm going to multiply x to the 5th by every term in our trinomial. And so x to the fifth times 8x to the fourth will leave me with 8. And then x to the fifth times x to the fourth. When I multiply the x's, I add their exponents. And so that will give me x to the ninth. Then minus 5x to the eighth minus 2x to the fifth. And we've distributed them out. Now remember, if I were given this as my original and asked to factor it, I would end up with that. That's what factoring is. It's looking to see what I can pull out of every single term. Just notice that means I can also pull x's out of every term. So let's see how we would do that with these examples. So for our first one there, I need to look at both terms, and I need to see what can I pull out of both of them. And you notice there's no number I can divide both of them by. I can't divide both of them by 10, for instance. So instead, I can look at the x's because both terms do in fact have x's in them. And so I'm going to go ahead and factor out some x's. Specifically, I see that I can factor out x cubed. And so I'm going to start by writing the x cubed out front. Now, how do I know that I can pull out x cubed? Because x cubed is the smallest exponent I have on any given term, which means that I can pull the 3 x's out of that term. And because all the other terms have more than 3 x's, I'll be able to pull 3 out of all of those as well. All right, so if I'm going to pull out the x cubed here, x to the ninth divided by x cubed is not x cubed. Sometimes that's the error I see people make. You're doing x to the ninth divided by x cubed. Remember that when we divide our variables, we subtract their exponents because basically I can cancel out 3 x's from both the top and the bottom. And so that's going to actually equal x to the power of 6. So this first term is x to the sixth. Then minus 10x cubed divided by x cubed is just going to be 10. Now, if you were questioning whether this actually is correct, you can always try multiplying this back out and looking to see if it does indeed give you what you started with. And in this case, yes, it would. If you multiply the x cubed into the binomial, you will get what we started with, which just confirms that that is our correct factored form. All right, let's go ahead and go on to that second one then. So again, I want to look and see what is the biggest thing that I can pull out of every single term. And, you know, if I'm looking at my numbers here, 20, 11, and negative 25, nothing divides out of all 3 of those except for 1. And we don't want to pull out 1 every time because you could do it forever and ever. So what else can I pull out? And you'll notice that every single term includes some x's. And so we can pull some x's out of every term. Specifically, I can pull out 6 x's out of every term. So I'm going to do that. I'm going to pull out x to the sixth and write that out front of my parentheses first. No numbers can pull out though, remember, so all the numbers will stay the same. So the 20 is still a 20, but instead of x to the eighth, if I take 6 of those 8 x's out, I'm left with 2 x's. Then plus, the 11 stays an 11. In this case, I have x to the seventh, and I'm taking out 6 of those x's, which means I'm just going to be left with 1 of those x's. But I don't really want to write 11x to the power of 1. X to the power of 1, it's correct. It's just not quite as clean as we could make it. So rather than writing x to the 1, I'm just going to write that as 11x. And then minus 25. I'm taking out all 6 of those x's, so it's only the 25 left behind. So this would then be our final factored form for this particular problem. And in our final set of examples, we are again going to start by doing some distribution, but in this case, you'll notice that the term, the monomial, that is out front of the parentheses includes both number and variable. But now that we've seen how to do it with each of them individually, you hopefully will be able to tackle that fairly straightforward because it uses all the same stuff that we know. So for instance, when doing this first one, I'm going to be multiplying the 4x cubed into both of those. 4x cubed times x to the 7th will be 4x to the 10th. And then minus the 4 times 2 is 8, and the x cubed stays the same because there's no x in that last term in our binomial. All right, then on to the next one. Again, I'm going to distribute this 10x to the 7th into all three terms of my trinomial. And so notice I'm going to start by doing 10 times 4, which is 40. And then x to the 7th times x to the 5th is x to the 12th. Because when I multiply my variables, I add their exponents. Now, if you can get that term, you can get all the rest as well. So then it's going to be plus 130 x to the 10th, and then plus 10x to the 7th. And do notice that if I wanted to have this 10x to the 7th hanging out there on the end, there had to be a 1 inside the parentheses for me to multiply to. That's going to be an important piece because a lot of people miss that little detail and it throws them off later. Let's go ahead and now factor with those. So for our first one here, I start by looking at my numbers in each term. So I got a 12 and I got a 3. What can I divide both of those by? Well, I can divide both of those by 3. So I'm going to start by pulling out a 3, but that's not everything I'm going to pull out here, because I also need to check and see the x's. And you notice I do have x's in both terms of my binomial. And so I can pull some x's out. How many? Notice I can pull 4 out of both terms because my smallest exponent is 4. So I'm actually going to be pulling 3x to the 4th outside of my parentheses here. That's what I'm going to factor out. All right, now I can go ahead and do that division. And so 12 divided by 3 is 4. And then x to the 6th divided by x to the 4th is x squared. So the first term is 4x squared. And then the plus stays a plus. And then the last term there, 3x to the 4th here. If I do 3 divided by 3, that's 1. Okay, and if I do x to the 4th divided by x to the 4th, it cancels itself out. It's also 1. And so what a lot of people will want to do there is, I've seen a lot of people say, oh, well, then it's just going to be that. It's just going to be the 4x squared and call it done. But it's not, because you notice if I multiplied that together, I would get this 12x to the 6th, yes, but there would be no plus 3x to the 4th hanging on the end there. And that still has to be there. And so remember how I was saying we have to have that 1 in there? Since 3 divided by 3 is 1, we have to have that 1 still there. That way, if I did multiply that back into the parentheses, I would, in fact, get the same binomial that I started with. If there's anything that I see as kind of the single biggest stumbling block in these types of problems, that's it. All right, now then, let's go ahead and go on to our last one. So on the last one, again, I start by looking at each of my numbers. So I look at 4, 28, and 8, and I look to see what can I divide all of those by. And it looks like I can divide them all by 4. So I'm going to start by writing down a 4 there. And then I'm going to look at any x's and see, can I pull x's out of every single term? And since there are x's in all of them, yes, I can. The fewest number of x's in any term is 2 of them. And so that's how many I can pull out of all of them. I can pull out 4x squared then. And now it's a matter of just doing that. So if I do 4x to the 9th divided by 4x squared, the 4 divided by 4 is 1. And the x to the 9th divided by x squared is x to the 7th. So I'm just going to write x to the 7th there. I could write 1x to the 7th. That would still be technically correct. It's just that when there's a 1 in front of x, we don't have to write it in, and we do tend to omit those numbers that don't have to be there. Okay, now I get to the minus part. 28 divided by 4 is 7. X cubed divided by x squared is x to the 1, which remember we just write as x. And then plus 8 divided by 4 is 2. X squared divided by x squared is 1. So 2 times 1 is 2. And so that then is our final factored form. As you get better about manipulating these different forms, we will then be able to start getting into seeing how this is useful, because by factoring out these terms, we end up being able to write our equations and expressions in different ways that allow us to see things that we couldn't see otherwise. And it's actually going to make some of our work that we do later a lot easier. So make sure you really do get this factoring down. And now it's time to go practice it.